Assalamualaikum and hello everyone. Welcome to the video for 4.3 isomerism. Where in this video, we're going to define chirality center and enantiomer, identify the chirality center, explain optical activity of a compound, and draw a pair of enantiomer using 3D formula. Okay, so we have learned about stereoisomer. Previously, we have learned about cis trans, right? So in this video, we're going to look at the last type of isomer we're going to learn in this chapter. Okay, so on your notes, it will be on page 12. Okay, so the last type of stereoisomer we're going to learn is about optical isomerism. The other name for it is actually enantiomer. Okay, so here it mentioned that the optical activity is the ability of crystal or solution of certain substance to rotate the plane of plane polarized light. And when the substance that can rotate the plane is said to be optically active, and the optically active substance is actually possess similar structure formula but differ in the effect of plane polarized light are called optical isomer. So it means that actually it have the same structure formula tapi dia ada different arrangement of atom in space. Okay, so for the cis trans, we have learned there are requirements for the molecule to exhibit the cis trans isomerism. The same goes for the optical isomerism. The molecule must possess certain requirement lah, possess certain characteristic. So the first one for the requirement of optical isomer is actually the molecule must contain a chiral carbon or chirality center. So what is a chirality center? Chirality center is an sp3 hybridized carbon atom with 4 different group attached. So again, other name for it is actually simple nak tahu. It must have 4 single bond and each of the bond tu must have different atom. Okay, and then for the chiral carbon tu, we must label it with asterisk. We're going to label it as star. Okay, so for example A, let's do it together. Okay, yang ini dia dah buat macam ni kan, in 3D arrangement. Okay, so first we're going to check for this one. What we're going to check, because this is carbon, check for each of the carbon itself. So this carbon is actually attached to 3 hydrogen, right? So is it a chiral carbon? No, because remember must 4 different group attached. So this is not a chiral carbon. Okay, so for this case, this carbon, okay, this carbon attached to CH3, hydrogen, attached to nitrogen, and then attached to all of this group. So when we see it here, this carbon actually is attached to 4 different group. So here is actually our chiral carbon. So we have to label the star. Okay. But then for the case of optical isomerism, you have to check each of the carbon. Because remember chiral carbon, chirality center. So nitrogen, we're not going to check. Here carbon. The same goes here because it already attached to 3 hydrogen atoms. So it means that it is not attached to 4 different group. Okay, so next, here we have another carbon. Okay, this carbon here attached to hydrogen, OH, our benzene ring, and the carbon that attached to all of this. So here, since it is attached to 4 different group and it also has a 4 single bond, kan? So here is actually our chirality center as well. Okay. Next, actually, okay, this is benzene ring. Benzene ring is actually C6H6. So C6H6. But then again, remember we want it to be sp3 hybridized. So it means it have 4 single bond. But does it have 4 single bond? Maknanya A carbon ni ada 1, 2 single bond, 1 double bond. So this one, our benzene ring cannot be a chirality center ataupun chiral carbon. Okay, so this is actually, for this case, these two is our chiral carbon. Okay, so yang ini dah buat arrangement dia. It seems very nice kan? Kita sendiri dah tahu macam mana. Okay, how about if they given to you the molecular formula macam ni? So, how we're going to do it? So, first trick is actually, first step, what I'm going to do is actually, I'm going to make an expanded structure. So, for the case of expanded structure, first is CH3, and then this is the first carbon. Second carbon is carbon here. We have second carbon, hydrogen, and attached to it, actually our OH. So here, I'm going to write OH, and then here we have the third carbon is COOH, which is our carboxylic acid. So carboxylic acid is this one, C double bond O, OH. Okay, remember that for the chiral carbon or the charity center, check each of the carbon itself. So this carbon, can it be a chiral carbon? No, because it attached to the same atom 3 dah kan? So this is not a chiral carbon. Okay, so this carbon, okay, attached to one OH, one CH3, one hydrogen, and another one C double bond OH. So here you have, it has 4 different group attached. So this is actually our chiral carbon. Okay, next is our COOH. Okay, but then here what it has is actually 2 single bond and 1 double bond. What we want is actually here, sp3 hybridized carbon atom, which is 4 single bond with 4 different group attached lah. Okay, so for this case, this is actually our chiral carbon. So for a given compound, what you're going to do is actually check each of the carbon itself. But for example, C and D here is actually a cyclic structure where it shows, they ask you to determine, is it a chiral carbon or not? Okay, for cyclic structure, dia macam tricky a bit, but let's do it together. Okay, so for this one, what I would like to do is actually first I'm going to draw a line here. So macam draw in the middle dekat yang dia minta tu kan. So I'm going to draw here. Okay. So maknanya dia nak tahu this carbon is it chiral or not. So this is actually our carbon. But then what I would like to do is actually I'm going to make an expanded structure jap. So here is actually CH2. Here pun CH2. Remember, each carbon must have 4 bonds. So CH, CH, CH. This one pun CH, CH, CH. Okay. So, from this, then it is easier for you to know. Contohnya sini middle C kan. Okay, sini H dengan CH3. So, we're just going to draw ni H, ni CH3. So, this one. Okay, how about the cyclic structure ni? So that's why I would like to draw a line in the middle, because actually kat sini senang nak nampak. Sebenarnya dekat sini CH2, CH2. Okay, this one is actually this one. Okay, and then this carbon pun attached pada CH2, CH2 sini kan. So here I'm going to take CH2, CH2. So when we check it here, is it attached to 4 different group? Okay, ni hydrogen, CH3. Okay, they're 2 different. Okay, CH2, CH2. Tapi ni pun CH2, CH2. So, because it has 2 of the same group, so this is not a chiral carbon. So, this lah, not a chiral carbon. Okay, so this is the example C. Now let's look for example D. This is a cyclic example, but then here it shows to you 2 of the carbon itself. So let's look. Okay, first thing first, I'm going to do the first one here. Okay, so what I'm going to do is actually I'm going to draw a line here, and then what we're going to do is actually make it expanded. Okay, in this case, we're going to draw, this is carbon. Here is carbon. I'm going to draw the carbon. And then make sure each of the carbon must have 4 bonds. So here must have hydrogen as well. My carbon here. Here, 1, 2, 3, 4. 1, 2, 3, 4, 3, 4. Okay, so this is for the case of carbon here. Okay, so for that carbon, okay, so it is bonded to OH and bonded to H. OH and H is actually this one, and it's bonded to CH2, CH3. Panjangnya. Okay, the CH2, CH3. Okay, and then this part is CH2, CH2. So here CH2, CH2. So this is for the carbon here. Okay, so when you look here, is it a chiral carbon? Okay, when you look, it's bonded to OH, H, okay, 2 different group. Here CH2, CH3, here CH2, CH2. So here we have 4 different group. So it means that this is actually a chiral carbon. So I'm going to draw a line here, an asterisk. I'm going to label it as an asterisk. Okay, and then next one, we're going to look for this carbon. Okay, so for this part, actually when we draw it here, ke sini kan ada carbon here kan. Yang ini you don't have to include it as well lah. Sebab yang ini line dia betul-betul kena dekat sini kan. Okay, there's no need for you to include. Sebab tak tahu nak include dekat sini ke, nak include for this one. So it's fine. So let's look for this case. For this case, I'm going to use the red one. Okay, so it means that the carbon here is bonded to hydrogen and CH3. So I'm going to draw hydrogen and CH3. And then another one is actually we have Here this case, kat sini kita akan ambil yang CH2 ni. We're going to take this CH2. So here our CH2. Okay, this one CH2CHOH. So CH2CHOH. Okay, so this is actually, when we see it here, we can see it is bonded to 4 different groups. So this is actually a chiral carbon, which we have to label with our asterisk. Okay, so actually most of it, it will given to you based upon the molecular formula like this. Ini memang tricky question lah if it's given to you. A cyclic structure. So for a cyclic structure, memang the hint is actually we have to draw a middle line, and then you have to draw this one lah, yang show what is 4 different group tu. So then check if it has 4 different group, then we have to label it as asterisk. It means that the molecule contain a chiral carbon. Okay, so that is the first requirement. Okay, so once the molecule, we have determined that the molecule contain a chiral carbon. Next, what we're going to do is actually, when the molecule contain a chiral carbon, it's actually the molecule itself is not superimposable with its mirror image. Okay, so for the case of enantiomer ni, it's important first to determine the chiral center. Next is actually to draw this one. Okay, so how to draw this? This is actually, once you have drawn, that's why I would like to draw in terms of this one, because later we're going to draw the 3-dimensional image of the molecule to know the arrangement in space. Okay, so how we're going to draw it? Later, we're going to do it together. But then again, this is actually an example of our chiral carbon, right? It's bonded to 4 different groups. Okay, so here it mentioned that in plane, the in plane, so that's why we have one line and one line here. Okay, bond that lie behind the plane. Kat sini, we're going to draw a wedge here. A dash wedge here. A dash wedge. And yang wedge kat sini, yang tebal ni, is actually bonds that project out of the plane. Okay, the arrangement of atom tu tak kisah yang mana. Tapi yang paling pentingnya, for the 3D image tu, you have to know mesti ada ni lah. Ada 2 line yang macam biasa, ada 1 wedge, ada 1 dash wedges. Okay, once you have draw one part, and then we're going to draw the mirror image of it. So kat sini lah yang example dia. So make sure the chiral carbon tu memang kena bonded to 4 different group. Then we can draw this part, and then we have to label it as enantiomer, the name of our isomerism itself. Okay, so let's look for the examples. Where what we're going to do is actually based on the structure itself, we're going to determine whether or where is the chiral carbon, and we're going to draw the mirror image of it lah, or the enantiomer. So let's look for example A. Okay, so for example A, here we have our condensed structure. What we're going to do is actually we're going to make it into an expanded structure lah. So by now actually you should be able to draw it by yourself. Okay, next, based on this structure, what we're going to do is actually we're going to determine which one is our chiral carbon. So what is a chiral carbon? First, we have to make sure that the carbon is sp3, where it has 4 single bond, and there are 4 different groups attached to it. So what we're going to do is we're going to check each of the carbon tu lah, which one is our chiral carbon. Usually it has minimum 1. Okay, so for the first structure here, we have carbon. Okay, does it have 4 single bonds? So we have 1, 2, 3, 4. Okay, and then based on the carbon here, we can see it is attached to hydrogen, 1, 2, 3, and attached to all of this lah. Okay, so as we can see, actually it only attached to 2 groups, because it only attached to hydrogen and this structure. So there is no 4 different group attached to this carbon. Sebab the 3 one is actually similar lah. So dia bukan 4 different group. Hence this carbon is not a chiral carbon. Next, what we're going to check, the carbon next to it lah. Okay, so this carbon, okay, is it sp3 or we have 4 single bonds? So we have 1, 2, 3, 4. Okay, ngam. Next, does it have 4 different group attached? Okay, so how we're going to check? So tengoklah carbon ni attached pada hydrogen di atas, OH di bawah, COOH di kanan, and kiri dia ada CH3. So it has 4 different groups. Hence, this is our chiral carbon. Since this is our chiral carbon, don't forget to label the star dekat chiral carbon kita. Okay, next, check lagi carbon kita. Next carbon ni. Okay, so carbon ni, does it have 4 single bond? Okay, so it only has 2 single bond and 1 double bond. So this one is not a chiral carbon. Okay, so from this structure, once you have determined which one is a chiral carbon, next we're going to show that this carbon is attached to 4 different groups. So it will be easier for us to draw it in terms of 3D structure. Okay, so how I'm going to draw it? Okay, so I'm just going to show the chiral carbon ni. Okay, ada 4 bond. Okay, so next yang group attached to it, I'm going to draw it in terms of condensed structure lah. Okay, so here COH on the left. Okay, bawah dia kita ada OH. Atas dia kita ada H. And on the left we have CH3. Okay, don't forget to label the chiral carbon. Okay, so this is the structure. Okay, so it's the same one. Sebenarnya ni dengan ni sama saja. But why do I make this one? So that it will be easier for us to draw the in terms of the 3D structure lah. Okay, so macam mana nak draw the 3D structure? You still remember nak draw kita punya tetrahedral dia macam ada atas dengan kaki ayam. Cumanya kat sini ada extra, kaki ayam ni ada yang in terms of 3D. Okay, so macam mana nak draw? So I'm just gonna draw, okay, carbon, okay, di atas satu, okay, di kanan sini satu, kaki ayam kan, 1, 2, 3. Okay, lagi satu ni we're gonna draw a wedge. Okay, so draw a wedge tu maksudnya sini lah. Okay, dia tebal sikit. And then we have ada dash line dekat belakang ni. Okay, so kalau dash dia jadi macam ni lah. Okay. So sini dia ada 4 single bond. Sebenarnya sama lah kat sini ada 4 single bond. So sebenarnya mana-mana pun kita boleh letak lah. Okay, so what I will recommend, selalunya kita akan ambil the most yang atom yang paling besar. Yang paling panjang kita akan draw di atas. Okay, so I'm just going to draw COOH at the top here. Okay, and usually at the back ni kita akan ambil the smallest one. So the smallest one will be hydrogen. Okay, so yang ini, so ini dah write down, H pun dah write down. So what we have ada CH3 dengan OH. So tak kisah nak letak mana-mana. So I'm just going to draw this one CH3. So lagi satu ni mesti OH. So this one is our in terms of 3D structure. Okay. So tapi enantiomer ataupun optical isomer ni adalah mirror image kan. So what we're going to do, we're going to draw a mirror here. Maksudnya line dash 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 kita. Dash 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 dash. Okay. So what we're going to do, kalau mirror image, okay, dia macam adalah reflection. So reflection dia akan jadi, okay, C1 di atas, C1, okay, satu line ke atas. Okay, sekarang ni dia reflection kan. So what happen, sini akan jadi straight line kita. Ini akan jadi wedge kita. Ini will be our dash line. Ni memang ada reflection. We assume this one act like a mirror lah. Okay, tapi bila reflection tu kena ikut lah. Mana yang bond yang straight, yang just a straight line ni, tengok dia punya atom apa yang attach. Okay, so contohnya I'm going to take from up here. So COOH. Okay, kat sini we have dash line. Dash line kita ada H. Okay, salin balik. Okay, and then we have wedge line ni CH3. Okay, CH3. Okay, last but not least, we have OH. Okay, cumanya remember, based on this line, carbon is attached to oxygen. So make sure carbon ni, sini oxygen kita. Then this one will be hydrogen. Baru betul mirror image. Kalau kamu buat carbon jadi HO, ini salah lah. Sebab carbon sebenarnya attached pada oxygen. Bukan attached pada hydrogen. Carbon ni attached pada oxygen dulu. Okay, ini baru betul kira. Betul-betul reflection kita lah. Mirror image. So last sekali jangan lupa label. This one is our enantiomer. Okay, if the question asks you to draw the optical isomer or the enantiomer for a compound, for a given structure, for a given molecule, first what you're going to do is from the condensed structure, make it into expanded structure. Okay, why? Because it will be easier for us to determine which one is the chiral carbon lah. Okay, chiral carbon must have 4 single bond and 4 different group attached to it. Once you have determined which one is the chiral carbon, next it will be easier for you to draw the enantiomer. Okay, so you're going to draw it again. I'm going to make it condensed again. But then again, for the chiral carbon, must have 4 single bond lah. Okay, next step barulah boleh buat yang the 3D structure. Okay, so it is recommended. Okay, kalau structure yang panjang tu, the longest one will be at the top lah. Supaya nanti bila kamu draw mirror image, it will be much more simple. Okay, usually we're going to take H as the back lah. Okay, yang kita punya wedge line, our dash line ni. Okay, so for the mirror image, don't forget to draw the mirror and as well as label it as enantiomer. Okay, so that's for question A. Next is for question C. Okay, question B, you try yourself. Okay, for question C, what we're going to do first, again, what we're going to draw it in terms of our expanded structure. So this is the expanded structure. Next, we're going to determine which one is the chiral carbon. So we're going to check each of our carbon lah. Okay, so first we're going to start with the left. Okay, this carbon, okay, does it have 4 single bond? 1, 2, 3, 4. Yes. Does it have 4 different group attached? Okay, it has 3 hydrogen attached dengan CHOH, CH2, CH3. Okay, but then since we have 3 similar, so it will not be a chiral carbon lah. This one is not. Okay, next carbon, does it have 4 single bond? Yes. Okay, does it have 4 different group attached? So tengoklah, carbon ni attached pada hydrogen, attached pada OH. Okay, on the left is CH3, on the right is CH2, CH3. So it's different CH3 dengan CH2, CH3 is different one. Okay, so this one is our chiral carbon. So don't forget to label the carbon here. Okay, next carbon. Okay, so this carbon, it has 4 single bond. Okay, ngam. Okay, but then we can see carbon ni attached pada CH. Ada 2 hydrogen, 1 CH3 and one of on our left ni lah. But then again, because dia ada 2 similar kan, so this is not our chiral carbon. Okay, the last one but not least, this carbon, it have 1, 2, 3, 4. Okay, but then again, sama macam first case tadi, where it has 3 similar hydrogen lah. Okay, so tak adalah 4 different groups. Sebab we have 3 similar atom. So in this case, we only have only 1. Okay, so next step, once we have determined this one, we're going to draw it in terms of yang ini, the simplified version. So carbon, we have 1, 2, 3, 4. Okay, so we're going to draw. Okay, yang atas ni, H ni. So we're just going to write down H. Okay, bawah tu OH. Okay, OH. Okay, on our right ni. Okay, on our right, kita simplifykan dia. It's actually CH2, CH3. And on our left is actually our CH3. Don't forget to label our chiral carbon. Okay, so next what we're going to do, we're going to draw the 3D structure first. Then we're going to draw the mirror. Okay, so 3D structure again, satu line. Okay, atas. Yang kanan ni, lepas tu ada satu wedge. Okay, ada satu yang dash line. Okay, so kita recommended this one at the top here to be the longest ataupun yang paling panjang lah. So bila kita consider this 4, this one yang paling panjang dia. So sini kita tulis lah. Okay, so again at the back, simple kita ambil hydrogen. Okay, yang lain tu macam nak ikut yang sama pun boleh CH3. So contohnya kat sini nak buat OH pula, nak ubah-ubah kan. Sebenarnya tak kisah arrangement. So sini CH3. Okay, tak kisah pun. Okay, so next what we're going to do, draw the mirror. Okay, so sama juga. Okay, carbon ada satu atas. Satu di kanan. Okay, satu di kiri dia pula, sebab mirror kan. Okay, satu yang wedge, satu yang dash-dash. Okay, so bila mirror image, satu senang. Yang panjang ni kita buat di sini. Supaya tak adalah kita pening. Macam mana nak terbalikkan dia. Okay, or how is the reflection. Okay, ni hydrogen. Sama juga. Macam ni. Okay, so OH pun sama. Mesti tunjuk the carbon is attached to oxygen and hydrogen. Okay, so yang ini pula, yang this carbon attached to CH3, right? Okay, so dekat sini kena buat lah. Sebenarnya simple buat. Attached to carbon, buat H3. Okay, yang ini kita kena tunjuk macam ni. Okay, in terms of mirror image, itu memang penting untuk kita kasih dia yang terbalik. Kalau untuk ni, sebenarnya tak kisahlah CH3 macam ni boleh diterima. Nak buat CH3 macam ni pun diterima juga. Tapi untuk mirror image, kena memang betul-betul bagi dia, kita kasih terbalik lah. Okay, ada reflection. Okay, jangan lupa last sekali label the enantiomer. Last but not least, let's look for example E. Okay, so again, what we're going to do, okay, from this structure, we're going to draw the expanded version. So once you have drawn the expanded version, you're going to check each of the carbon, whether it's a chiral carbon or not. Okay, so actually, for this compound, we have 2 chiral carbon. Carbon here, carbon number 2, and carbon number 3. Okay, so for carbon number 2 and carbon number 3 here, what we're going to do is actually Maksud dia ada 2 chiral carbon. I'm gonna do both of chiral carbon with different arrangement lah. Okay, so how we're gonna do it? Okay, I'm gonna do the first one ni. I'm just gonna change it to yellow. Okay, so for the example of yellow ni, so same juga. So this is the arrangement for the chiral carbon with the yellow one lah. How about the pink one yang ni? Okay, oh, forgot to label it with our star. Okay, the pink one ni. Okay, so let's draw it. Okay, so for this case, we have 2 different chiral carbon. So just for this example, I'm gonna draw. How about if I make this one as my enantiomer or the optical isomer? Okay, so this one is quite different sebab on the right hand side and the left hand side is quite long. Okay, tapi sama juga. If anything, kita akan draw carbon ada 1, 2, ada wedge dengan ada dash. Okay, so again, kalau yang wedge ni kita akan ambil yang paling simple. Yang at the top ni depends on you. Nak buat CH3 CHOH ke? Nak buat CH2 CH3. Okay, so prefer sebenarnya lagi panjang, nampak macam CHOH ni kan? Okay, so next kita check. Okay, this carbon, the chiral carbon ni sebenarnya, okay, if you look back here, the chiral carbon dia attach pada yang CHOH dahulu. Okay, so bila kamu draw, kita akan buat macam ni lah. CHOH. Okay, so CHOH baru CH3. Okay, depends kat kamu nak buat CH3 sini boleh, nak buat macam ni pun boleh, ataupun nak buat CH3 at this side pun boleh juga. Okay, tapi make sure the chiral carbon ni attach pada yang CHOH ni. Okay, bukan pada CH3. Kalau kamu buat dia CH3 CHOH akan salah lah. Okay, so senang, bawah ni kita ambil OH sahajalah. So OH, okay, and then this one is CH2 CH3. Okay, so this is our 3D structure. So for the enantiomer, we're gonna draw the mirror. Okay, so how about the reflection? So let's do it. So carbon ada atas, depan, wedge line, and then we have dash there. Okay, so this one, kenapa kita akan take the top as the more long molecule ataupun the largest molecule? Sebab kat sini tak perlulah kamu nak buat reflection apa-apa. Salin sahaja balik. Lagi senang. Okay, so sini H, sini OH. Okay, so for this case, remember carbon ni sebenarnya attach pada carbon yang ini. So when we draw it, carbon CH2 CH3. Ni betul-betul mirror image. Okay, sebab tu senang. Kalau atas ni kita ambil yang paling panjang lah. Sebab nanti bila kamu buat mirror image is the same one. Last but not least, jangan lupa label enantiomer. So that is for the example E. Okay, yang ini for this example, I'm gonna I only draw the second one yang inilah. Okay, so for example B and D, you should try yourself.